Hi, I'm Ben Canning, and I've got another set of lectures for you. This one's a macro lecture, so we're talking about kind of the introduction to this collection and this unit. Specifically, this collection is going to be focusing on the effect of acceleration on velocity. As always, you need to do 3 bullet points worth of notes, a 1 to 2 sentence summary, and any of the follow-up questions on the Google form. Alright, so let's return to the same big idea that we've had before, which is how do we describe the effects of pushes and pulls on the motion of something, and how do we predict those effects? So for example, if we have a dragster here and we double its engine, does that double its speed, or does it change something else, or does it triple its speed or quadruple its speed? What is the mathematical relationship or the pattern that is associated with that? So that's what we're trying to aim towards. Another example might be if we have a boy pulling a wagon, then how does the speed or velocity of the wagon, how is that affected if he's pulling twice as hard or 3 times as hard, and things along those lines. The focus of this unit is going to be on acceleration and it letting us be able to quantify changes in motion, and that's really what this is all about. And the reason why we're doing that is because if we can quantify those changes, then we can make precise descriptions as well as precise predictions about these changes and the effects of these changes. And that might be useful so that it can allow us to predict future locations or positions of something even if speed is changing. Last unit we talked a lot about being able to predict where something will be if its speed is constant, but what if its speed's changing? So like if we have this snowboarder here and he's launching off a ramp, can we predict where he's going to land without having to watch him land? So just by knowing his speed coming off the ramp and maybe how his speed is changing in the air, can we predict where he'll land? This would be important because you don't want to be the first person going off a ramp if it's built way too far away or way too close. You want to be able to build ramps and predict where our snowboarders or skateboarders or anyone going off ramps of this sort is going to land prior to them landing. The focus of this collection is really going to focus on acceleration and velocity, meaning the relationship between those two things. We're not going to get into position and distance yet, that'll be in the future. This one will focus again on acceleration and velocity. That's it for this one. 3 bullet points worth of notes, 1 to 2 sentences of summary, and any of the follow-up questions on Google Forms.